morning. Could we switch on the slides, please? There we go. So my name is Nico Scapel. I'm the head of rigging at Framestore, and I was the rigging supervisor for Gravity. So thank you for inviting me to speak today. I'd be very happy to give you a little overview of the work we did on Gravity, the challenges, and the journey we had to try and solve these problems. So there's a lot of material to go through, but I'll try to give you a little overview of what were really the key challenges in making the film and the thought process and how we came up with solutions. So Alfonso Cuarón is a director that we had worked with previously on Children of Men, and is the kind of director that really knows what he wants and will get really the best work, I think, out of anybody he works with. And he's got a few signature things, which are his long shots. And he had worked with Framestore on Children of Men with Tim Weber. We went on to supervise Gravity. Got a little...
Explorer, this is Houston.
Go ahead.
Sorry, I'll start with a little clip of Gravity for those who haven't seen the film or want a little refresher. And there's a little cut because I can't play the 17-minute opening shot. It would take a big chunk of my talk.
Explorer's been hit. Explorer, do you read? Explorer, over. Explorer. Astronaut is off structure. Dr. Stone is off structure. Dr. Stone's detached. You must detach. If you don't detach, that arm's going to carry you too far. Listen to my voice. You need to focus. I'm losing visual of you. In a few seconds, I won't be able to track you. You need to detach. I can't see you anymore. Do it now.
That's fine.
Houston, I've lost visual of Dr. Stone. Houston, I've lost visual of Dr. Stone. Do you copy?
Yes, I copy. I'm
Give me your
detached.
position.
I don't know. I'm spinning. I can't.
Report your position.
GPS is down. I can't. It's down. I can't.
Give me a visual.
I told you nothing. I see nothing.
You have a visual of Explorer.
No.
You have a visual of ISS.
No.
You need to focus. Anything. The sun and the earth. Give me coordinates.
I can't breathe.
Give me
I can't breathe.
coordinates. Dr. Stone. You're burning oxygen. You have to sip, not gulp.
So where's home, Dr. Stone?
Lake Zurich, Illinois.
Is there somebody down there looking up, thinking about you?
I had a daughter. A little girl with brown hair. Tell her that I'm not quitting.
So believe it or not, that film actually started as a side project he was doing with his son Jonas, and he wrote the script, and I think it was after Harry Potter, and they wanted to write something that wouldn't require a lot of special effects. So he thought, he's going to do just a real-time story, just something you can shoot, and with just a very few characters and a few sets, not many locations. But at the same time, while seeing the work on Children of Men, we knew he was not going to settle for something that doesn't look very realistic. This is the shot that we did. That's work from 2006, Children of Men. And in that sequence, there are actually people that believe that a real baby was used for filming this. And I think with his story, he wanted the same thing, and the film to feel like it was just like an IMAX documentary. And actually, while we were making the film, he was quite adamant that we don't talk about how we make the film, so people would actually come out and wonder if what was shot and really it would feel like it was just shot in space. which presents a few challenges. So first off, it was quite clear that NASA wouldn't let us just go up there and shoot stuff and blow up some very expensive equipment. So we couldn't really shoot there. The performances, he didn't want to compromise the motion. And in 0G, or to be more precise, microgravity, there's no up, down, left, and right. So there's a big question of how we do that. Very long takes, photoreal look. So each one came with some questions. For the location, that meant doing a lot of full CG sets and environments. For the performance, that was a tricky one, wondering if wire rigs would work or any traditional techniques. With the very long take, came with its own set of problems because that means you'd have nowhere to hide, basically, and you'd be seeing stuff from far away, from very up close, the same asset with no cuts. And the look, just something has to be completely photoreal, so it brought up some question about how we were actually going to render this. Now I'll talk about the methodology, how we approach this. The most important thing, I think, and that's the key reason why we actually managed to do the film, because I think at the beginning everybody was really questioning whether we would be able to do this, is that this was done in partnership with a studio, with us at Framestore. So everybody's sitting together from very beginning to end. It was a 3 or 4 year process, and that included the director who sat with us in the studio for a few years, producers, editorial, art department, everything in-house, the post-production. Framestore actually had a satellite office at Shepperton while we were shooting on our network. So there was no walls, and for a film of that complexity, you really can't go with the usual approach of shooting something and then opening this up to companies and having an ad hoc process, because if this was just shot with wires and then it would have turned out completely different on green screens. So coming to the filming in 0G, so the obvious thing was, well, is there any environment where you can shoot in 0G? There's actually one thing that exists, which is called a 0G plane, and it does these parabolic flights, and you can get about 2 minutes of microgravity in there. I think Sandra Bullock, the main actress, she was in 2 plane crashes, so she's not too keen on doing this. Putting all the lighting equipment would be impractical. There's a lot of, and for the long shots, of course, it's not very practical. Actually, after Gravity came out, Framestore did a commercial, and they used a 0G plane. And I've got here some outtakes of actually trying to shoot a very small action on a 0G plane. So here they were trying to squeeze some Robinsons, I think, into some water. So in the commercial it actually works, but in reality, there's a lot going on that plane. It's quite a mess. It'd be hard to fit 30 people. All right, this is where it gets messy. People don't actually talk about the 0G plane, they call it the vomit comet.
No flash. This is ludicrous, isn't it?
So not the best environment for our A-listers. So now, how do you put people in? How do you put people on wire or something so that you have that movement? So we looked at different types of rigs, so wire rig and flying harness, and rig with a rotating waist ring. And it quickly became clear that we could do this for shots at the interior of the space station where you see the actors without the suit. We would have to film it. So we'd have to use something like this, but also not being a spacewalk, they wouldn't be, the shots wouldn't be so long and the camera wouldn't do all these 3D movements. So we had to go for something like this, but with more control. So I'll touch base on that later. But for the spacewalks, it was clear that we wouldn't get the movement we wanted from these. So the bodies would have to be mostly full CG. The big question was the face. So how do we get the actual face on screen? And here you really have to think about what actually is a face on screen? What are the parameters? If you think that's a function, what are the parameters? So you've got the appearance, the performance of the actor, the camera point of view, and the lighting. So if we want to get these faces, somehow we need to get these 4 ingredients. If you're filming something, you're capturing all 4 at the same time. If you want to do any of those in post, essentially you're capturing, and then you're going to do some kind of reconstruction process. So we've got the actors, we're happy how they look, how they act, we've got the first 2. Now how do we get the camera point of view and the lighting? So these are questions. That's where robots come in. These are KUKA robots. They're used in car manufacturing. And a few years ago, a few companies start releasing them and seeing what you can do when you put a camera at the end of it. So a few people from Framestore went to San Francisco, and they met with a company called Button Dolly. And they have 3 of these robots, and we ended up using 1 or 2 of those. So the idea is well, you put the camera at the end of that, and basically that's what's driving the camera. And you can program these very, very precisely. So the idea with this is, well, what if you could choreograph the motion of the camera beforehand, and you essentially just play it back? So that was a good way to potentially do the camera movement. The next question is the lighting. So for a shot like this, this is a previous rendering. You see how fast the lights move around her, and it's quite impractical to move studio lights so fast. And obviously, you could put the actor on the end of the robot arm and trying to rotate them. Again, I think it would be unhappy actor and a tricky insurance contract for them. So there we had to think outside the box. Well, actually, we had to think inside the box, which is called the light box. So the idea with this is, instead of rotating, moving the actor about, moving the physical light, is to use all these LED panels and actually play back the lighting in this box. So with this technique, you only care about the relative movement of the face relative to the lighting. So you play back the lighting from the point of view of the face, and you can light the actors. And for a really strong light source, you can combine that with some physical lights. We use that for the sun. So I'll go back in more detail on this, but this gives you the key ingredients of how the film was shot. So because of these 2 techniques, it's quite clear that if you use the robots, if you use the light box, you actually have to do the whole film before you shoot anything. You need the exact staging and the position of the head of the actor relative to the camera, and you need to have all the lights. So that meant doing the film the other way around, backwards, which I think is actually forward, because that's a great way to make a film. That means you start with the previs, and you actually have to render the whole film before. You don't have to do it to a final quality, but you have to do it with enough detail that later it's going to work. So for the previs, Framestore actually, by that time, just started a partnership with the 3rd Floor, which is a great previs company based in LA, and now they have an office with us in London. And the previs process started very early. Actually, we had a few animators. I think they were staying at Alfonso's house, and basically with a few computers and doing very early on storyboards. And as it evolved, it became clear that everything would have to be previs to great detail. And here I'll show you some little clips of Alfonso working with the animators. So we had all the assets basically of the film done to a low resolution version. They had to be pretty accurate dimension-wise, but obviously all the models are kind of mock-up, and it's all stuff that we completely redid in post. So there were more detail about the placement of the head than the action on the body, but they also had to think about the camera composition and the lights. The filmmaking is quite unusual because there's no up, down, and left and right, and there's a lot of let's play this. There's a lot of seamless camera moves. So we used, for the long shot, we used different approaches. We used some ragdoll simulations for very long shots that were driven by physics mostly. We used some virtual camera techniques, so we could reshoot. We could do an animation, and then Alfonso could do some camera work on capture stage. So this was a long work to choreograph all that action, and we had some storyboard to start with, but it's really during that stage that the whole film was built, and it was a partnership with Alfonso and a few animators that basically worked together to figure out the shots and the story. And that's where I think there's huge value in this project, in the approach, because a lot of decisions have to be taken very early on. And once we start seeing finished sequences in previews, you had a very good idea of what the film would be like. It was just a matter of making it look pretty. So I will play some final previews so you can get an idea of that. So this is a segment of final previews for the opening sequence. So the shots were so long, like the opening shot is 17 minutes, but we start cutting that into beats. So there were actually 17 different beats in that shot that could be managed like shots. So the previews here gives us the choreography point of view, the position of the actor, the camera. But for the lightbox, we also need all the lighting. So after the previews, we had a phase called pre-light. And that was basically rendering the whole previews. We use a physically based rendering. We start with Modo, and then we ended up using Manta Ray, just to have a really fast workflow. Nothing was rendered to a very high resolution or detail, but what was important is to get something physically accurate and we could reproduce later. So Alfonso has been working for years with Chivo Emmanuel Lubezki's director of photography. And using that physically based renderer, we're able to basically work with, he called the team that he worked with, he called them his digital gaffers, because basically he was being on a virtual set, and the only tools that he had is where the earth was placed, where the sun was placed, and where the environment was placed. And it was basically the lighting and putting bounce cards, and really he was lighting this environment as if he was lighting a virtual set. So they were, just like the previous, there was a lot of interactive lighting sessions with him sitting at a desk and playing with the lighting. So you can see what typical pre-light results would be. And so the language of lighting was actually changing when we were working with him, because he was talking about blockers and bounce, etc. The only difference would be that the bounce light would be possibly 1 kilometer away, or the distance. It was playing with a set that was absolutely massive. So once this was established for the lightbox, we actually had to then render the lighting, but from the point of view of the helmet. So it looked like this. So this is a lat-long rendering. And that would then be projected into the lightbox. We use a real-time software called Touch Designer. A lot of VJs actually use to project that on the walls. And there was a whole system of being able to retime this as well. So to prepare the shoots, we established basically what the techniques would be. There was detailed blueprints for the lightbox. But also, if you think about these complex motions, the movement of there are some restrictions with the lightbox that the camera can only look through a little gap in the box, because obviously you have to try and cover it with lights, but you have to also leave space for the camera. So you have to find the right compromise there. And actually, you can't really get the whole motion with this, so you also need to move the actor in order to get the relationship right, you cannot reverse engineer the motion. So you put some motion on the actor, some motion on the camera to try and make everything work. So here I'll talk about the shooting process. So that's when Framestore start having a little office at Shepperton. And they built this stage, which was, I visited that a few times, and it was pretty amazing. This big, it was usually in the dark, and you had this big light box there. The actor was there for many hours a day. It was a really strange place. And on the left there, all the artists were there, and big difference with the usual set is actually there were a lot of changes still happening there with the flexibility of the system. There's a team of people that could actually work through and retime some moves, work with the actor in real time. So this is some early tests with, not with the actor yet, just to see that everything is going well. And here you can see the movements. So the actor was also on a motion control rig, so we could also move them around. And there were 1 or 2 people that had a very stressful job. They were there all day in the corner of the box with a big red button to make sure the robot didn't get too close to the actors. So this is the typical shot and the data that we bring on set to be prepared before shooting. So you can see the pre-light on the top left, and bottom left you have the camera move. So that's one really important thing with these robots is you can kind of control them, but you need to program everything in advance. To program some complex moves, you actually need to solve the motion. And in rigging, which is my discipline, we work a lot with IK, and these robots, it's all about IK. You've got certain numbers of degrees of freedom. The robot has 6 degrees of freedom, but we added a few at the end, so we had 11 degrees of freedom. And we've got the movement of the actor and the robot, and there was a whole process called TechViz, where we had to try and solve and find a camera move that would be valid for the robot, so it wouldn't go too fast, or we work for all the constraints of the kinematics of the robots. And then bring on the programming on set. There were some shots with more complex interaction with the set, like this one, where we'd use a combination of techniques. So here on this one, it was the light box, but this time it was a wire rig for the movement. So the LED light box could be configured, the panels could be moved based on the needs. For the interior shot, there was a 12-wire rig, and this one was also all motion control. So there was a little controller, so you could actually remote control the actor. And we actually had some puppeteers from Warhorse, I think, that were moving the actors about. So this was used for inside the space stations. So this shows you an example of that scene. So all the interiors fully digital. So instead of having sets that we then track or scan, we actually build the digital sets beforehand, and then they built or printed in some cases the proxy version of the set. They would be out of foam or light materials, and they were accurate, very accurate to our dimensions, but it didn't really matter what they looked like. It was just really to get the right bounce of lighting and the right contact points, because it was really important that she makes contact at the right places in the set. So this is the very fast-forward view of the opening shot to show you the variety of setups that were used. So the opening shot actually had 17 different setups, whether it was 1 actor, 2 actors, on the wire, inside or outside. So now I'll talk a little bit about the process of bringing that back. So you have this whole process of reverse engineering the previs to program the lightbox, program the robot. You end up, and then there are some changes being done on set, and now we need to bring back that performance and our hero assets and put it all back together. So the first step for all this data was to track really accurately the helmet. So in all these plates, really all that we're going to use is inside the visor. Everything else, there will be some useful reference for animation, but we're not really using any of the body movement here for all the spacewalks. So having tracked the helmet, that gives us basically that vignette. And now we need to realign this to match the final animation. So there was a bit of a dance there between what was shot and what was animated to conform the footage to the animation, but also for the animation to be sympathetic to it. So there's only so much you can change, because basically the point of view is already fixed. So you could move the actor in a way that the perspective would be the same. So we had some special tools, so you could move the actors a bit like a billboard. So they'd be facing the same way. You couldn't really turn them a different way. They had to use moments when they were turned away to do some transitions. And we had metrics to measure how much disparity we're introducing. So that was really a new process to find out if you cheat the perspective a little bit, at what point you start seeing that something is strange. So we found that there was a few degrees that we could get away with. After that, you'll start to lose the illusion. So the body animation was all keyframed. We had, as reference, we had a lot of NASA footage. We shot a lot of mocap, and it was useful to some extent, but because it was all shot in gravity, nothing was really used directly. All the props motion was also animated by hand. So animation had long briefing session. They had some courses on the physics space, and spent a lot of time trying to get all the interaction with the equipment as accurate as possible, trying to use the cues from what the actors were doing in the suits, because the body had to feel like it belonged to the head. So that was really tricky to try and make sense of the movement they were doing, but still have that match with the head. So now I'll talk a little bit about the process after the animation. So for the post, we use physically based rendering, but we switched to the Arnold renderer. So that was the first project at Framestore using Arnold. We now have a site license, and we use that pretty much on all projects. So the idea with that was to start by looking at our NASA footage and see if we could match that look. Here's an example of lighting session, and you can see just the effect of rotating the panels, the effect it has actually on lighting Ryan. So this was, again, another example there, just changing the angles of the panels. So as I was saying, it's a very different approach working that way, because you really have to think about why things are lit a certain way, and change the environment so that it's lit properly. So these are different things I could play with, the time of the day, configuration of panels, etc. Obviously, there was only so much that could be changed versus what was done in pre-light, because it still had too much lighting on the face. So because of the long shots, full CG environments, we knew that the big challenge would be building the assets as well in space. I'll show you a few examples there of the work on the vehicles, the space vehicles. So we had all these lined up with NASA images. So working with this, NASA provides a lot of amazing reference in very high-res imagery. So we tracked actually some of the images, tracked our models in there, and kept rendering until you couldn't really tell which was which. Because the camera also gets so close, a lot of rendering tricks couldn't really be used in a way that we needed to have actual geometry representing pretty much every nut and bolt on these things. So the amount of geometry on these assets was pretty mind-blowing. This is the Chinese space station. So it's not finished, so there's only a few modules are done now. So a lot of the modules had to be designed based on little information available. And the International Space Station. So we build each module separately, and we had the exterior model and the interior model. It's the Soyuz. So we can see here is the model is taken to very high level of detail. Here I've got zoom in view so you can actually see, this is actually wireframe. You can see the amount of detail. And then beyond that level of detail, the actual, there's this micro displacement, which is basically based on scanned samples of fabric. So that even beyond that, you actually see the 3D thread of the fabric on these. The suits was probably the biggest challenge in terms of 3D asset that we had to do. You see it moving from very close, very far. Great detail, it just has to be there, and it's very close to the face. So they actually build physical suits, and there is just one or two shots. It's one shot when Matt, it's a dream sequence, and he comes in the capsule. And if you actually look at that suit, you'll see, I don't think it looks as good as the CG suit. They spent a fortune building this, but it's actually, an actual NASA suit is something they spend years, and it's millions of pounds and years of R&D to engineer. It is really it is like a vehicle. It's got all these different subsystems. Every part has been engineered to death, and actually you can't really build a very convincing, even the best prop companies don't have the resources to build something that really looks like a NASA suit. So we started by taking that physical suit that had been built and started building a model of that. And then we realized we had to actually go closer to the actual NASA suit. The thing with the NASA suit is actually it has a hard shell underneath, and actually gravity would have been less exciting if we had been really truthful to the suit, because the actors would just be doing this. And there's not much movement. You can't really raise your arms above your shoulders. Your whole trunk is actually encased in a solid armature. So we had to take some liberties, but we kept a lot of the functioning of the suit, especially the articulation system, because there is so much fabric, you can't really bend it. So there's actually, it's articulated pretty much like a robot with different joints. So if you rotate your wrist, you're actually just rotating the whole glove. You don't get any torsion of the fabric. Now, to actually get the tailoring to work, and especially on the Russian suits, which are the so-called suits, which are full-body suits. We also had to think about, well, how are we going to model this kind of accurately? If we're going to do some simulation, we need the right amount of fabric on these suits. So instead of doing the usual approach of just sculpting this, we started from the patterns. This is software called Marvelous Designer, and this was used early in the process of designing the suits and trying to basically create the patterns to build a suit. It's basically a virtual stitching program. And so that helps you finding out, well, if you got that amount of fabric and you stitch it a certain way, you'll get certain pleats. Because of the amount of detail, none of the folds and wrinkles are displayed, so there's actually that much fabric in all these suits. So we could then simulate and unfold the wrinkles. So you can see the amount of detail on those. And for the simulation, we really had to think about all the different properties, the different material, and what's underneath all these parts. So in terms of resolution, the NASA suit alone was over 1 million polygons, and that's probably about 50 times what our normal hero character would be. But if you think about the length of the shot and the scrutiny that you see, it's almost like the suit is actually a whole set. And this shows you a few iterations, small sample of iteration. You can see version 400. This is one of the first shots where we bring the footage and the asset together. And up to that point, we really didn't know what it would. We had no idea what it would look like to put the stuff that we had filmed inside the suit, because we didn't have the footage, we didn't have the suits, and it was still a big question, because we knew that the perspective would be slightly different, the movement would be slightly different, and nobody knew if it would be jarring or if it would just work. And this is the first shot where we saw it and thought, okay, we might have a go at this. There were a few shots where we couldn't lock these 4 factors: the appearance, performance, camera point of view, and lighting. So where basically the action was so fast or not really well defined in previs, we wanted to have a bit more freedom in the end to change the motion. In this case, we couldn't really shoot the faces with white lighting. So there were a few shots where we used digital heads. So we used a system called MOVA, a facial capture system. So in terms of capture, it's not really animating a face. It's more capturing moving scans of the actor. So you're not really talking about redoing or animating any performance. It's really kind of a different way to photograph them so that you can change the point of view and the lighting in post. So we use them. So the great thing I think about this film is how we avoided actually doing CG faces for all the close-ups, because you could spend a fortune and get the best technology out there. With the current state of the art, it's great, but you're still very far away, and I think we're many years away from having perfect one-to-one. So with this technique, it was actually limited. There was a limit to how big the face would be allowed to be on screen. So we kept it about 8 screen height. And to get better quality textures as well, we augmented the system with a few film cameras to shoot the face from different angles. And so we had great geometry from the MOVA system, and we had higher resolution textures as well. So this is an example of what it looked like. Here the face is bigger than it would be in the actual film. And actually the lightbox and the other shooting setups worked quite well, so we didn't really have to use this as much as we thought we would. So here you can see this is a lightbox, but just before there was a brief moment when it was a CG head, and basically you can't really tell, which is exactly the point. I'll talk a little bit about the simulation effects. So the big ISS destruction sequence required very heavy simulation. So we use a system based on bullet physics, multiple levels of detail, to basically break down the ISS into components of increasing detail. So based on where an impact would be, we'd be able to go down to that level of detail. And could do both rigid or non-rigid deformation. Show a few simulation results there. Had to be combined with finer debris, sparks, and fire explosions. We also had a lot of simulation assets that you wouldn't necessarily think about. One of the trickiest ones was actually the tether, because it's there on screen for a very long time. And it's the silhouette that it creates was actually part of the storytelling. So it was a great exercise in trying to do something that is fully simulated, but very, very easy to art direct. So we had quite an intricate system of being able to control where it went and the tension to really art direct the simulation. So we actually spent a lot of time simulating and rigging cables and tethers of various lengths and properties, as well as the suits, of course. So to wrap things up, I'd like to share a few thoughts about what the whole process meant for us, and I think how it opened our eyes to different ways of making films, and we're hoping that because more and more directors will be taking these crazy ideas and experiment, because I think it's such a fun experience for everybody involved when you start with something that is quite new and nobody really knows how to do it, and it brings the creativity from everyone, technical and artistic. I think what changes really this film is, at the beginning we thought, okay, it's actually a backwards way of doing the lighting before shooting, but actually once you go through it once, I think it's a really great way to go forward. And I think there's a shift starting to happen in that direction now. You even have more and more, and the future is definitely going to be towards being able to previs in real time, do real-time visual effects. The idea with all this is you can make a lot of decisions early on in the process where the iterations are fast. You can react, things don't cost too much, you don't have you don't have any bottlenecks in communication. And I think the nature of 3D has changed a lot. It used to be something very cumbersome and expensive, but it's not anymore. So actually, I'll play this, you remember what it was like in the 90s.
Man, this place looks expensive. I feel like I'm wasting a fortune just standing here. Better make the most of it. Ow! Watch it, Coney! Yeah! Oops.
So this is some work done by PDI when I used to work a few years ago. But it kind of illustrates what was the gap between 2D and 3D in a way. So the traditional, I would say, the most projects now try to spend as much time in physical world shooting stuff rather than doing in 3D. So we do previs more and more, but then a lot of things happen on shoot that are unplanned, or there's a lot of changes. And then we spend a lot of time tracking that material, conforming to it, and it's only when we light stuff that we actually go back and composite that with the original material. So it starts in 3D, but it's actually really the 2D, the live action is driving the 3D. With Gravity, the workflow is different because it's really a 3D film where the 2D, the live action shoot is like capturing elements that go into this 3D film. So the process spends a lot more time on that side of the equation with the previs, the tech viz, pre-light that kind of bridges the gap, And the shoot actually is in both worlds because you're actually shooting and capturing. So you're not just shooting material that you then have to track from scratch. You're actually shooting something that is very controlled. After that, you have some new processes like the conform, where you really marry what you've shot with what you've prevised. And the lighting and compositing are also more straddle both worlds a lot more. So if I have time, I'll just play a little reel of a compilation of what everything I've talked about through the film, the various effects being used. So I think that wraps it up. Thank you to the whole Framestore team, amazing crew working on this film. It's really a pleasure and honor to be working with all these people.